All right, if you're building pretty much anything on the web today, you are dealing with traffic. But, the way we manage that traffic has had this massive shift. So forget what you thought you knew. Today, we're going to dive into the modern workhorse for web applications, the AWS Application Load Balancer.
Think about it this way. In the old days, load balancers were kind of like a basic traffic cop at an intersection, right? Just waving cars through, one by one, not really caring what's inside. The modern way? Oh, it's like having an intelligent dispatcher who knows exactly what's in each car, where it's trying to go, and the absolute best route to get it there. It's a total game changer.
So here's our game plan. We'll start by breaking down what makes this dispatcher so smart. Then we're going to see why it's so incredibly powerful for today's apps. We'll peek inside to see how it thinks, and importantly, we'll understand its limits. And then finally, we'll see why it's become the go-to choice for almost everybody.
Okay, so let's start with the fundamentals. What exactly is this smart traffic dispatcher we're talking about?
Well, the secret sauce, the magic, is that the ALB operates at what's called Layer 7, the application layer. And the key phrase here is inspection of the actual content. It's not just looking at the address on an envelope, it's literally opening the envelope and reading the letter inside. And this is the perfect way to see that difference in action. An older load balancer, it might only see the myapp.com part of that address. But an application load balancer, an ALB, it sees the entire thing. It sees the path, /API/orders. It can read the headers, check the cookies, everything it needs to make a really intelligent decision about where to send that request.
Okay, so it's smart, I get it. But what does that intelligence actually do for us? Let's take a look at how this all translates into some incredibly powerful use cases in the real world. This is really where the ALB becomes absolutely essential for modern apps. If you're running microservices, say for an e-commerce site, you can send requests for /users to your login service and /orders to your shopping cart service, all from one single load balancer. Running containers? No problem. The ALB can route traffic to a bunch of different containers on the exact same machine. It can even route requests directly to serverless Lambda functions. It is literally built for the way we build applications today.
And its superpowers don't stop there. Beyond that smart routing, it natively supports modern protocols like HTTP/2 and WebSockets, which is huge. It bolts right into the AWS firewall for better security, and get this, it can even handle user authentication before a request ever hits your server. Plus, it performs these really deep health checks to make sure your app is actually working, not just, switched on.
So we know what it is, we know why it's so powerful, but how does it actually make these decisions? Let's pop the hood and break down the ALB's thought process.
It's actually a pretty simple three-step process. First, you've got the listener. Think of this as the ALB's ear, just listening for traffic on a port. Next up, you have the rules. This is the brain. This is where you define all that logic, like, hey, if the URL path is /images, do this. And finally, you've got the target group, which is simply the destination where that request gets sent. An ear, our brain, and a destination. That's really.
And here's the key to its flexibility. This isn't just a one-to-one system. A single listener can have dozens, even hundreds of rules that send traffic to all sorts of different target groups. This one-to-many relationship is what gives it such incredible power. Now, as powerful as the ALB is, let's be real, it's not the perfect tool for every single job. To be a true expert at anything, you have to know its limitations. So let's talk about when an ALB might not be the right choice for you.
This is a question every single cloud architect has to ask themselves. And the answer, of course, is no. There are some very specific scenarios where you're going to need something a little different.
Okay, the biggest limitation, the one that comes up the most often, is that an ALB does not have a static IP address. It uses a DNS name that can resolve to multiple IPs. So, if your client absolutely requires a single fixed IP to connect to, you have to use its cousin, the Network Load Balancer, or NLB. The NLB is built for raw, extreme speed, and non-HTTP traffic, while the ALB is all about that flexible, intelligent web traffic.
And just a couple other things to keep in your back pocket. Because the ALB is reading all your traffic, it has a tiny bit more latency than an NLB. Now, we're talking microseconds here, but for something like high-frequency trading, that stuff matters. And there are some hard limits, like the size of request headers, that you just can't change.
So after weighing all of that, the power, the flexibility, the limitations, where do we land? What's the final verdict on the application load balancer?
The answer is pretty darn clear. For the vast majority of modern web applications, and we're talking about 90% of them, the application load balancer is the correct standard choice, period.
So here's the bottom line. The ALB is designed from the ground up for flexibility and modern architectures. Unless you have one of those very specific needs we just talked about, like needing a static IP or extreme low-level performance, the application load balancer should be your default choice, every time.
And that brings us right back to our original analogy, doesn't it? So take a look at your own applications. Is your traffic being handled by a simple traffic cop just waving things through? Or have you upgraded to the smart dispatcher? Because that choice can make all the difference in the world.